First question is explain relation between zeros and coefficients of a polynomial. Let ax square plus bx plus c is one polynomial. Then these a, b, and c are called coefficients. And let the zeros are alpha and beta. Then what is the relation between alpha, beta, and this ABC? That is given by here alpha plus beta equal to minus b by a, and alpha beta is c by a. C, this is the constant term c by a. If a is there, generally a will be 1. But you remember the relation. Explain the geometric meaning of zeros of a polynomial. What exactly does 0 mean? When you graph the polynomial like this, like this, like this, we are graphing the polynomial. Graph may cut the x-axis at one place, many places, or it may not cut at all. Here you see, it is cutting x-axis, again cutting x-axis. It is cutting y-axis, we are least bothered. And it is touching y-axis here, it is cutting y-axis here. Cutting y-axis here, 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 in 4 places. These x-coordinates of these points, x-coordinates of these points are called zeros. What's the difference? Here, y-coordinate is 0. Here, y-coordinate is 0. Here, y-coordinate 0. Here, y-coordinate 0. So, therefore, the x-coordinates of these 4 points are the zeros of the polynomial. What is the polynomial? Polynomial you can see in the shape of a graph. Px polynomial. Now, we will go into the example given in your textbook. Example 1. Look at the following graphs of the polynomial y equal to px. Find the number of zeros. You see the graph and tell me how many zeros are there for this polynomial. This red one is polynomial. This red one is polynomial. It is cutting, number 1 is this, right? First problem. First problem. It is cutting the x-axis at only one place, at A. So there is 1 0, that is the answer. 2, it is cutting the x-axis here A and here B in 2 places. Therefore 2 zeros are there for this polynomial. For this polynomial is cutting at 3 places. So answer is 3. So similarly, everything goes like that. It is cutting y-axis, we don't care. We don't care to see this. It is cutting x-axis at only one point, so 1 0. 5, 1 0. It is touching, not cutting, touching. Even touching is cutting. 1 0. Problem number 6. It's cutting at nearly 4 places. A, B, C, D. Here, 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 here. So the answer is 4 0. Similar question is here in the exercise 2.1. Same question. You have to just count the number of places where it cuts x-axis. Suppose this is the graph given, this red line is not cutting the x-axis at all. So no zeros. Similarly, you can go to 2, 3 and count the points. Here there is only 1. Here there is 1. Here there is 2. Here there is 3. 3 zeros. Now let us go to example 2. Find the zeros of the polynomial. He has given the polynomial there. X square plus 7x plus 10. And verify the relation between zeros and coefficients. Okay. We have to break this polynomial into factors. X square plus 7x plus 10. Assume px is 0. Then that becomes equation. The roots of this equation are the zeros of this polynomial. Same thing. So equate this to 0. X square plus 7x plus 10 equal to 0. So here there is 1, here there is 10, 10 times 1 is 10. Split 10 into factors. 2 5s is 10. And 2 plus 5 is 7. So, we settle these factors. X square plus 5x plus 2x plus 10. 7x can be written as 5x plus 2x. So, you will get, here x is common in these terms. So, I have taken x. X times x plus 5 plus, here 2 is common in these two terms. 2 times x plus 5. So, x times x plus 5 plus 2 times x plus 5. In this expression, we have x plus 5 common. So, we take out x plus 5. X plus 5, if you take out, in this term you get x, in this term you get 2. So, x plus 5 times x plus 2 equal to 0. That gives you, if AB equal to 0, either A is 0 or B is 0. So, if x plus 5 is 0, you get x is minus 5. If x plus 2 is 0, you get x is equal to minus 2. Those are the zeros. Minus 5, minus 2 are the zeros of the equation. There are 2 zeros. Now, checking. We should get what? Suppose this is ax square plus bx plus c. If you compare this, c is 10, b is 7, a is 1. Okay? So, sum of 0 should be minus b by a. Here we are getting sum of 0 is minus 7. Here minus b is minus 7 by 1. Minus 7 by 1. Minus b is minus 7. Sum of zeros is checked. Similarly, product of zeros must be equal to c by a. What is c there? What is c there? That depends upon polynomial, right? 10. 10 is the c. A is 1. So, c by a is 10. No, product of zeros how much? Minus 2 times minus 7 is 10. This is 10, this is 10. So, c by a is 10. Check. That means product of 0, product is c by a, we got, and the sum of zeros minus b by a, we got. These two are settled and found to be correct. Example 3. Find the zeros of the polynomial x squared minus 3 and find the relation between the zeros and coefficients. Similar question, but there is no x term here. So, we can write x square plus 0 times x minus 3. If you equate this to ax square plus b plus c, a is 1, b is 0, c is minus 3. So, the roots are kept. So, equate first, px is 0. This is px. This is x square minus 3 is 0. That gives you x is plus 3 plus root 3 or minus root 3. Sum of the roots is 0. B by a 0. Minus b by a 0. Sum of the roots is 0. Root 3 plus minus root 3 is 0. B by a is also 0. Product of the roots. Plus 3 times minus root 3 plus root 3 times minus root 3. This is minus 3. And c by a is also minus 3. Settle. Example 4. Same thing. Find the quadratic polynomial, the sum and product of whose zeros are minus 3 and minus 2 respectively. That is one example. So, here people confuse. People may take this as alpha, this as beta. I have taken like this. This is wrong. Actually, he has given alpha plus beta equal to minus 3. Alpha beta equal to 2. So, what is a polynomial? X square plus sum of the roots with minus sign times x plus product of the roots. This is a polynomial. So, px is x square product sum of the roots minus 3 So x square minus of minus 3x plus product of the roots 2. X square plus 3x plus 2. This is the answer. Here something I have written. Just read and leave it up to here. Just read and leave it. Px is x square minus alpha plus beta times x plus alpha beta. That is the algorithm we use here. Cubic polynomial. If the degree is 2 like this, if degree is 2 like this, it is called quadratic polynomial. If degree is 3, it is called cubic polynomial. Ax cubed plus bx square plus cx plus c. In this case, the relation between the zeros and alpha beta or gamma are alpha plus beta plus gamma is minus b by a. Alpha beta gamma is minus d by a. Alpha beta plus beta gamma plus gamma alpha taken 2 at a time is plus c by a. So just remember in 10th class this is not important. In 10th class, it is not important. Now you can go to exercise 7.2. Find the zeros of the following polynomials and verify the relation between zeros and quotient. First, he has given one polynomial, equate it to 0 like this, and then split it into factors. You find zeros. Sum of the zeros must be minus b by a. Product of zeros must be c by a. You check like that. You check, you can read and you can gather. 2, 3, 4, 5. There are 6 sub-problems here. The most confusing thing here, children, get is they have to compare this to ax square plus bx plus c. And there should not be 0 here. There is no theta. Next, question number 2. Find the quadratic polynomial, the sum and product of whose zeros are respectively given below. I have to show you, right? I'll just take them very slowly. So that you can copy, you can pause and copy. Now question 2. Find the quadratic polynomial, the sum and product of whose zeros are respectively given below. Here people think this is alpha, this is alpha, this is beta. No, this is wrong. This is alpha plus beta. This is alpha beta. That is how the question says. Whose sum and product are given. Sum is this, product is this. So alpha plus beta is 1 by 4. Alpha beta is 1 by 4. We know if alpha plus beta are known, the polynomial will be ax square, x square, if we know alpha plus beta and alpha beta, the polynomial will be x square minus alpha plus beta times x plus alpha beta is the polynomial required. We have written the same thing here. You can go, I will just scroll the problems so that you can just copy. There are almost 6 problems there. That's it. Chapter Polynomials is completed here. Please subscribe Thathamatics channel.